All right, so this is our last few sections here. We've got 7.1 and 7.2. And in these sections, we're going to talk about functions of several variables. So in this first example here, I have c of x comma y equals 700 plus 70x plus 100y. Up until this point, we've really only looked at functions of the form, y equals f of x equals 2x squared minus x plus whatever the function looks like, right? Our function only has this one variable. Now we're going to start to talk about functions of two variables or three variables or four variables. We have multiple variables. And what's cool about these is if you think about the types of functions that we've looked at so far, this y equals f of x. When you graph this on an xy coordinate plane. You live on a flat piece of paper. And regardless of what it looks like, here we have a parabola. Perhaps it looks something like this. It's a two-dimensional shape here. When we start to look at these functions of several variables, so here I have a function of two variables. Another way I could write this is z equals 700 plus 70x plus 100y. Another way I could think about this, if I was to graph this is no longer a two-dimensional shape because I have x, I have y, and now I have this third variable z. So I don't live in two dimensions or two space anymore. I actually live in three dimensions and three space, which is where you and I live. So if you were to graph this, what you would actually see, rather than living on an xy coordinate plane, you would live in the x, y, z coordinate space. So here you would have x, y, and z right here, and you would actually have three-dimensional shapes. So imagine this is kind of like the corner of a wall or the corner of a room. And that's what it would look like. You would live in three-dimensional space, and we can do all sorts of really neat stuff with these. We can graph these three-dimensional shapes, and then we can start to ask really cool calculus questions like, okay, what does a local minimum look like in three space? Because you can actually have things which are local minimums if you look at them from one perspective, but actually local maxima from another perspective. It's very cool. But we're going to just focus right now on the very, very basics of this here. So we're just going to start by just getting used to these functions of several variables here. So here I have this cost function, like I said, c of xy equals 700 plus 70x plus 100y. I want to find c of 20 comma 10. So really in this first section, we're just going to get used to working with functions with several variables, just kind of evaluating them. So if I wanted to look at c of 20 comma 10, I'm going to take 20, I'm going to plug that in for x, I'm going to take 10, plug that in for y, and then evaluate the expression that I come up with. So 700 plus 70 times x, we said x was 20, plus 100 times y, that's 100 times 10. Here I've got 700 plus, what do I have here? 1400 plus, this will be 1,000, so I've got 21, I should have 3,100 here. There is my result. So really I just want to get used to seeing functions of several variables, working with them, evaluating them. This first section is going to go really, really quick. So we can also write familiar geometric formulas as functions of two variables. So if you look at, say, the volume of a cylinder is pi r squared h, where here my volume depends on both r and h. So when I say find v of 5 comma 4, I'm really looking for the volume of a cylinder who has a radius of 5 and a height of 4. But I'm just going to take these two and plug these in. So v of 5 comma 4 equals pi times r. R, we said that's 5, so 5 squared times h is 4. So here I have pi times 25 times 4, which would be 100 pi. And you could, of course, go get a decimal approximation if you wanted to, but I'm going to leave my answer in terms of pi.